the last talk of the first day of the conference. Glad to see that you make it. I'm really happy that Devnexus is getting back to traction. Even though that's my first trip to Devnexus, I planned to come here many years ago, but then we all know that the pandemic changed the plans of many. However, eventually we can get together here and enjoy a lot of interesting conversations and topics. My talk is about cloud environments. It's about Spring Cloud. It's about your applications and how you deploy those applications across multiple availability zones or regions if you want to achieve high availability. If you want your applications to withstand all sorts of possible cloud outages, because sometimes availability zones go down, sometimes entire regions go down, but ideally you want your applications not to be impacted, right? And first, when it comes to this high availability focus, let's define the term of geo-distributed applications, what those applications are. If you Google for this term, then you might come across several resources. One of the resources would be from Microsoft, because this is actually the place where I learned about this term initially. And geo-distributed application is an application that spans across multiple geographies. On this picture, you can see that the boundaries of the geography is broad, and some application runs across multiple continents, right? But doesn't mean that if you don't create applications that work across multiple continents, if this talk is for you or not. It's certainly still for you, because a geo-distributed application is also an application that is deployed across multiple availability zones within a single region. So let's say if you're just developing right now for the United States market, and you're deploying in the United States West or East Coast region, and you're deploying that across multiple zones or data centers in that region, then you are effectively created a geo-distributed application. Or what also happens sometimes that your geo-distributed application can span across multiple regions that are in a relatively close proximity. For the United States, the relatively close proximity would be, let's say, an application that is deployed in the West, Central, and East. Because generally, many applications are fine with these latencies. All right, so now, these are the geo-distributed applications that you create. They are deployed across multiple geographies for high availability, performance, or compliance. And we are going to talk about high availability. Let's imagine that all of us are co-founders. Probably a big number of people who decided to co-found a company, but we decided to create a Slack-like messenger. Who uses Slack at work? Microsoft Teams? All right. So imagine that we decided to create some alternative. Probably we are reinventing the wheel, or we have some secret sauce in mind. But on a serious note, Slack actually is a good example of a geo-distributed application, because Slack runs across multiple continents, including the application instances, database nodes, and blah, blah, blah. And we created our first version of our messenger. And we, as a startup company, we don't have enough resources, we don't have enough money, right? We can easily go broke in a couple of months. We deployed the first version of this application somewhere in the United States, south, right, central zone. We have the instance, we have the database node. And then, unfortunately, many natural incidents happen in that region. The cloud region becomes unavailable, the power is down, and our application is down. One of our first users, Mrs. Blue, a financial advisor from New York City, she's disappointed, but that's not the end of the world, because we are a startup company. We are not, let's say, an established enterprise where you expect, high availability. But as a startup, that was a good lesson for us. We figure out that, yes, a cloud environment comes with abundant resources. You can easily deploy, virtual machines or Kubernetes pods whenever you like. But also this cloud environment doesn't give you high availability for granted. You need to take care of the high availability of your own applications, because cloud fails, and cloud fails frequently. So let's say we, as co-founders of this Slack-like messenger, we decided to do a research, by checking how frequently those outages happen across different cloud vendors, because probably we need to switch to another vendor, right? But in fact, every vendor fails. Sometimes it can be a minor zone-level outage. Sometimes it can be major region-level outage. Okay, based on some rough statistics, On average, every 50 days, we can experience one of the major outages in one of the cloud providers, in one of the public cloud providers. It can be AWS, it can be Google Cloud Engine, it can be Microsoft Azure or Oracle Cloud. And if just, to judge by the post-mortem page of Amazon that does a great job by documenting all of those major outages, on average, it takes 4 hours to recover from a major outage, which means that if you're an unlucky one who deployed your application instance in the US East Coast, and that East Coast becomes unavailable, then your application will be down for 4 hours, which might be a big deal. And if to give you examples like why it happens, some of the typical reasons, the hardware fails, let's say the power goes down, let's say the software updates can be buggy. Like we use many services of the cloud providers, and those services also can introduce bugs. One of the most notable, notorious outages that I remember was several years ago. Those days there was some AWS engineer. He was doing some, operational upgrade of the Amazon S3, that cloud storage. And he messed up a little bit with command line arguments. And that exception, instead of doing the upgrade, it brought down a lot of the instances, and that issue cascaded to many services of Amazon that were dependent on S3, and basically that was a chaos. And the whole East region of the United States was unavailable while that issue was being recovered. But anyway, we are not blaming Amazon here. It can happen to any cloud provider. That's just one of the reasons. Humans also do mistakes. Those who work for the cloud providers, they're also human beings, and they also do mistakes. And they also sometimes, if you randomly go and click Google for cloud outage, in the news you can find that, some cloud outage happened somewhere, and some services, some applications can be down. So generally, what lesson can we take from these statistics and etc.? We as application developers, we just need to accept the fact that a cloud outage can impact our applications. Hopefully never, but it can happen, let's say, in a month, in a year, in 5 years, in 10 years, but it can happen. It can become your problem. And if you accept this fact, if you deploy in the cloud, then ideally when you build your applications, deploy them across multiple availability zones, across multiple regions. It depends certainly on the severity and on the mission criticality of your application, right? Depends. So now, let's say that we, the creators of the Slack-like messenger, we learned the lesson. We figured, all right, we are going to continue using cloud because I'm not going to set up my own data center. We don't have the time, we don't have resources. And there is no new reason for that, because even in my private environment, my private data center can also go down, right? Nobody is protected. But instead, we are going to utilize multiple regions of our cloud provider. And we deployed our application instance, our Slack-like messenger in the US, East, Central, and West. Wonderful. And the next time, let's say the issue, we had, some incident in the US East Coast. That region was impacted. But our application, our messenger was up and running. Because why? Because we had application instances, we have the data available in the other parts of the country. And Mrs. Blue, our financial advisor from New York, she kept using their application, even though the latency was certainly higher, right? Because right now, her traffic, her request needs to travel to here, to this location, okay? And the next question is, when we are talking about the high availability, is this deployment enough? I say, Denis, okay, it all makes sense. If I want to take care of the high availability, if I want to withstand region, even like the worst case region level outages, should I just deploy across several regions where I have my customers and that's it? The question is yes and no, because there are some other parameters or inputs that can influence your type of geo-distributed deployment. Let's quickly review them, and then we'll do a little bit of testing. Let's welcome our 2 new users who joined our messenger. One of them is Mr. Green. He is a scientist from Berlin. He learned about our messenger and he decided to give it a try. And another one is Mr. Red. He is a musician from Mumbai. Also, the word of mouth. People started learning about our messenger. And then imagine that we, as the creators of this application, had the chance to talk to our users. And the first question we asked, what do you think about the application usage experience? And usually when we raise this question, people can reflect, by remembering how fast, how responsive our application is, how when does it work, or it's always, down. And Mrs. Blue, she says, oh, it's lightning fast. I love this messenger. It's really quick, etc. And why her answer is that? Because remember, she lives in New York, and we have application instances. We have the data also in the US East. Probably she lives also within the boundaries of the US East region of the cloud provider. And the 5 milliseconds number came from, I frequently use Google Compute Engine. And 5 milliseconds is the latency between different availability zones within a region. So let's say that my instance of the application is deployed in the availability zone A, but Mrs. Blue lives in, let's say, somewhere nearby the availability zone C. And the latency is going to be around 5 milliseconds. Okay, not now. And next, okay, I'm going to Mr. Green, who also decided to answer this question. He says, actually the app is nice. It's useful. I see why it's better than Slack, but sometimes it's not responsive. And the reason is because, like, for Mr. Green, his traffic needs to travel across, or should we say under the Atlantic Ocean, right, where we have the pipes and the cables. And that's the physics of law. And if you'll ask the last one, Mr. Red, he might be furious. He can go, come on, like, I can barely use this application. It's always hanging. I always need to restart it. And probably because of the distance, again, for him, the traffic needs to travel, across the land and under the ocean until it gets to the United States. So ideally, what we need to do, right, the first obvious step, if you have significant customer base in Europe or Asia or other parts of the world, then first step, we can easily deploy our application instances there, right? But also you need to do something about the data. And you also need to make data available there. And we'll discuss that in the end of the talk, how you can move data closer to the user. Anything else? Because that deployment is also sort of highly available, but it also takes into account the performance if you want people from other parts beyond the United States to have a good performance. Yep.
Question, you're over the question now, right?
Then you can ask.
So, for the messaging application itself, there are different users in different geographies. And there is going to be latency depending upon wherever you keep the center, right? Because the data has to be replicated across different places. How do you choose where it should be?
Yeah, so we'll discuss that. Yeah, in the end, in the Yelta, we'll have when we will start. That's a kind of. Yeah, I forgot to give you just some, agenda, because first we'll define the problem. No, that's fine. That's a fair question. Then we'll have a sample application, this first version of the messenger. We'll do some testing. We'll try to do the fault tolerance. We'll deploy in real cloud environment. And then in the end, we'll discuss what to do with the data, because the data, it's easy to deploy application instances whenever you like. But the hardest part is the data, because you need to replicate changes and you want the data usually to be consistent, blah, 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 many things. So finally, what else could influence your multi-regional, multi-AZ deployment is compliance. If it happens that you need to store data in specific locations, that also can influence how your geo-distributed architecture and deployment will look like. For instance, I think that everyone knows about GDPR, the General Data Protection Regulations law that requires to store personal data of the European Union citizens in Europe, not in the United States. And we have Mr. Green, who uses our application, but right now all his personal data, his messages are stored in the United States. So right now that's not a problem for our Slack-like messenger, because we are a relatively unknown company, and the regulations in Europe will just put a blind eye on us. But in the future, that can be a big deal, right? We need to be ready for expansion in Europe. And GDPR is not the only one example. For instance, if you take India, let's say that our messenger allows you to do payments. For instance, you can transfer money or you can buy some stickers or whatever in our messenger. Then if someone from India, does a payment, then the transactional information has to be stored in India. So you can use the compute in the United States. You can run this transaction in the United States, but then eventually the information about those transactions needs to be stored in India and not in the United States, which also can be a roadblock for your application that serves global user traffic. Okay? Just keep in mind. Another example, because many talk about GDPR, but that's just one of the most well-known examples of data regulatory requirements. All right, and we basically also need to figure out how to deploy everything properly if you ever decide to scale beyond the United States to different markets. So now, finally, to summarize, a little bit longer intro, but what those geo-distributed applications are. And geo-distributed applications are effectively multi-region or multi-AZ applications. You deploy them if you want to achieve high availability, you want to withstand zone or region level outages, or if you want to serve user requests with low latency, regardless of their location. And finally, that's for compliance. If you need to comply with regulations, unfortunately, this is what you cannot skip from your to-do list, right? This is what you need to do. Talking about the geo-distributed applications building blocks. So generally speaking, there is no much difference between geo-distributed applications and regular applications. Under the regular applications, I assume applications that run within a single zone, within a single region. Same as a regular application, a geo-distributed application might have load balancer. It will certainly have an application layer, your backend and front-end logic. It might have some API layer that is used by different, third-party integrations. It can have data streaming layer if your application nodes need to kind of stream different changes, and certainly you need to have the database. But what's the difference, the key difference between a regular application and geo-distributed one is that in the geo-distributed one, all of those components needs to be distributed. So for instance, you need to have multiple application instances, right, if you want to withstand outages. Your API layer also needs to withstand outages, meaning that you are, like if to take Con as the API layer, you need to have multiple Con instances in different locations. And same for the database. The database also ideally needs to be distributed. Spring Cloud. How Spring Cloud is helpful here? Because if you take a look at the definition of the Spring Cloud, that's a framework for building distributed applications. So exactly whenever you deploy, you can create a simple app and you deploy that app like our messenger across several locations. Then you can use a toolbox and framework to interconnect those instances. For instance, you can use distributed configuration so that whenever your microservice instance boots up, the instance can read information from some distributed configuration that is available in the cloud. Or you can do the service discovery. For instance, if you don't use Kubernetes service discovery, you can deploy this service discovery in the locations of your choice, and then each instance of the application or each microservice of your application can easily find each other. Especially that's extremely valuable in a geo-distributed environment, because you don't want to code everything yourself. Same for the routing, same for the load balancing. There are many components that are available in the Spring Cloud. And today, just take a look at it. By the way, anybody uses Spring Cloud? What component do you use? Functions? Function streaming, and you? What? Gateway. Okay, all right. How do you like it? Is it loud? All right. So what I'm going to use for the demo setup today is the following. We will be running everything in the Google Cloud. Again, I'm not convincing you to use Google Cloud. I just happen to use it all the times. Then we will deploy 2 Kubernetes clusters. One of the clusters will be in the United States East, somewhere in South Carolina or Virginia, and another one will be in the US Central. So 2 clusters. Each cluster will be running several pods. One of them will be Spring Config Server. So I just want to show you how it's easy to deploy. You deploy Spring Config Server, and that config server basically can serve configuration for all of your microservices. My Slack-like messenger right now has 2 types of microservices. One of them is the messenger, and this messenger is basically responsible for the key functionality of every messaging application and ability to exchange messages, right, between participants. And also the attachments one. And like I want to share some pictures, and that's the microservice that is connecting to Google Cloud Storage and stores your picture there, and then you can take a look at it. And this is, in this configuration, I will be having multiple copies of these microservice instances deployed in 2 different locations. And also we will be using multi-cluster ingress. You will see why, so that you don't bother, let's say, of deciding what cluster, what instance your, let's say, mobile application or web front end needs to connect to. Everything is already automated for you. I think that you also can use Spring load balancing and other capabilities to solve some of these issues. But if you kind of stick to some of the cloud providers, I'm just showing you different options that exist. YugaByteDB is just a transactional database for our application. That's it. It's distributed by definition. So let's do the first step, right? We want to turn our single process application into a into a geo-distributed one, which means that first I want to deploy my application instances across several locations. And I will be deploying in the US East and West. So what's already ready, folks? I prepared 2 Kubernetes clusters. One of these clusters is in the US Central. The second one is in the United States East. They are up and running. I have a bunch of nodes. Probably I didn't need that many nodes, but nevertheless. If I connect to and see, do I have any deployments in this Kubernetes cluster? Nothing is deployed yet. So the clusters are empty, and right now I am connected to the United States East cluster. This is what I have. So let's go ahead and deploy the first instance of my application of the Slack-like messenger. I'm using some scripts, but it doesn't make sense to look into the code. The code uses Spring Boot, Spring Data, Vadin for front end, some of the typical components if you're a Java developer. And then when I execute this script basically uses several Kubernetes commands to deploy my images, and those images are already in the Google Cloud registry, in their artifact registry. So what happened here, I deployed all of those 3 microservices. So let's see now how many deployments I have. I have these deployments. This is my config server. This is the this is the Spring Cloud component. So let's take a look at the logs. You can see that from the logs, their component is up and running, and to the attachments microservice already read the configuration from it, and also their messenger microservice. Those pods, those microservices are up and running. They connected to the config server that is defined in their config, and they just read all the information, what database instance to connect to, any other parameters. So this is one of the examples how you can use. Also, one of the versions of this Slack-like messenger, for instance, you can deploy it on virtual machines. In that configuration, I use Spring Cloud Discovery. Because if you deploy outside of Kubernetes, when you deploy in Kubernetes, it might be easier to reuse the Kubernetes discovery mechanism if you want microservices to communicate to each other. If you're deploying on virtual machines, then Spring Cloud is a wonderful thing to consider. This is what I used. So it's here. So let's take a look at our, let's take a look at the logs of the messenger microservice, the main one. And here is, let me take a look at their services. So the messenger microservice is exposed, meaning that I can connect to that one through this public IP address. Let's do that. So this is my stuff. So I'm not the best designer, but at least Vadin allows me to make something that doesn't look that ugly. So this is, let's say, the messenger. We have different workspaces, different companies. You can select something and then you do the test. You send different messages. If you go back here, you can see that Hibernate generates all this data. The data is inserted into the database. We'll talk about the database later. What else to show? One thing, if I want to upload, let's say, a picture, I have some pictures here. All right, it's uploaded, and it's stored in Google Cloud Storage. This is basically S3 of Google. And here, as you can see that, yes, this is, I just want to confirm that's the instance I'm connected to, right? This is the backend. And this is the picture, and this is picture is public. So for instance, if I go and open it, it will be downloaded, yep, on my machine. So that's the east. That's the instance from the east, because that's the cluster. Now I want to switch, I want to deploy the same instance in the US Central for the sake of high availability. Because if the east goes down, I want this messenger to be up and running, right? Remember. So several steps. First, I need to switch kubectl tool to the cluster in the central. If I'm not mistaken, the name is central 1. Switched, so let's confirm. We are there. So here is, if you check, I don't have any deployments. I should not have, yeah. Nothing is deployed there yet. And we can fix it. So right now I'm executing the same script that will deploy the same set of microservices and the config server, but now in the US Central region. Not yet. You know what I forgot to do? I need to go to the project directory. Cloud, Geo-Distributed. I have many versions. And then we go to the G-Cloud. We are going to the GKE scripts. GKE stands for the Google Kubernetes Engine. This is what it is. Okay, we are deploying in the US Central right now. Okay, it's deployed. The messenger, you see, services still are starting. Let's repeat. It's up and running. So now, let's disconnect from this one. Yeah, we are in Central 1. Let me open the logs of the just started instance in the Central. So I'm going to read the logs of this instance. No any requests yet. It just complains that it cannot automatically use the load balancing capabilities of the database, and it's warming up some cache. It caches some of their data. But still, that's the new instance that was just deployed in the US Central region. And that instance has its own IP address, as you remember. That IP address we can find here. So that's the east, and that's the west, or that's the central. We need to sign in once again because there is no any session management component. But here is, if you, let's say, go to the, what was the channel? Allergan in the United States. Yeah, we are getting this data. We also can send something from hello from central. And that's the IP address in the central zone, and that's a different IP address in the east. Here is no any streaming notifications, but if I refresh, if I go here, you get this data. So overall, it's easy, right? It's easy just to get and deploy your application, as many application instances as needed whenever you like. But right now I have a problem. I have just 2 application instances, and each application instance has its own IP address, and it's up to me to decide how, what IP address should be used by that user, by that mobile application, or by that user that connects, let's say, from Texas using his or her browser. And here is luckily, again, this problem is already solved for us. Depending on your cloud environment, I believe that every cloud vendor, they need to have a component that is called Global Cloud Load Balancer. So what the Global Cloud Load Balancer does, imagine that you can get a single IP address, and that IP address will be provided to your web front end, to your mobile applications, to your edge applications. So all of those clients of your backend logic of your service will be connected through that single IP address, or a DNS name that is associated with this IP address. And then when anybody connects to this load balancer using the IP address, the load balancer will make a decision what application instance will be responsible for handling this request. For instance, based on the user physical location and based on the availability of an application instance, one of them will be responding to the request. For instance, you know that Mr. Green is somewhere in Europe. He is in Berlin. And when Mr. Green pulls up his phone and decides to send a text message through our messenger, then the mobile phone connects to the load balancer, and the load balancer sees, all right, Mr. Green is in Europe. I have an instance of the application in Europe. Is that application instance available? Is it healthy? If yes, then the request of Mr. Green will be routed in here. If it happens that we don't have an application instance nearby, or that application instance is not available, then the load balancer will automatically forward the request of Mr. Green to another nearby location, which might be United States East Coast. You know, easy. So let's see how it works. So what I have, so let's disconnect from here. What I have, I've already deployed that load balancer, and you can find that load balancer if you use Google or whatever. It's called this way, it's called load balancing. This is my global load balancer. It's basically attached to those two Kubernetes clusters, and depending on my physical location of my laptop, the load balancer will decide which Kubernetes cluster will be processing my request. So let's do the test. So the IP address, you can find it on that screen, or you can also use this command, kubectl described this ingress and get me VIP. VIP doesn't stand for a very important person, it's just a virtual IP address. And that load balancer is deployed in the United States East Coast. That's why I see this error. What I need to do, I need to switch to my East 1 Kubernetes cluster, and then when I execute this command once again, I'll find this IP address. Now, let me open the logs. So right now, kubectl looks at the messenger instance in the East, and I'm expecting to see the logs here. I'm expecting the load balancer to determine that I'm closer to the East location than to the central one, and my request should be forwarded to the East, not to the central. That's my guess. I actually have not tested that. But anyway, we are opening this IP address, and that's a new session. You see that the load balancer really quickly forwarded this request somewhere. Password. So here is, yeah, they're a little bit, the logs are a little bit busy. Do I have any, yeah, I have inserts, but it's always easier to check, you know. Let me upload some picture. I uploaded this picture, and I can see that, yeah, this picture is uploaded through the application instance in the East, which means that physically Atlanta is closer to the US East than to the US Central. And load balancer made this decision. I don't need to do anything. I just need to configure that load balancer. It takes around 10-15 minutes. You just need to wait while the IP address is propagated, but that's it. And then that's no longer your responsibility. You can do something else. So let's check that that's the picture. Yeah, that's the picture that I uploaded. Finally, before we do a fault tolerance test, because that's the topic of high availability, right? So we deployed across United States Central and East for one purpose. I want to be up and running even when any of these regions go down. Usually in the history of the cloud environments, I've never seen that two regions were down simultaneously, which means that if East goes down, that my application traffic, the user traffic will be served from the Central, and vice versa. But now, before we do this test, we'll do this in a few minutes. Let's quickly talk about the database, because with the application instances, with the load balancer, there is a general pattern you need to follow. You write your code, you deploy it in locations of your choice, and then just simplify your life by using a global load balancer. And then you can simplify your life by using many components of the Spring Cloud. One of them is config server, discovery server, or whatever you need to use, like gateway, for instance. But with the database, unfortunately, when it comes to multi-ASIO, multi-region deployments, there is no any silver bullet solution. So when it comes to high availability, you need to make a decision by answering this question. What's going to be your RTO, or recovery time objective? For instance, if a database node goes down, or like the entire database goes down, how quickly the database should return to normal operations? For instance, for some applications, it needs to be done within a minute. For some of the applications, it needs to be done within 10 seconds. For some, it can be done, I don't know, like in a couple of hours, because my application is not that significant. It's used internally. But this is one thing to pay attention to. The second one is RPO, recovery point objective, or how much data loss to expect after the recovery. Because it depends on your, let's say, if to take one of the typical deployment options when you have, let's say, an active database instance, active passive configuration. You have the primary database instance, you have a passive database instance. The changes are replicated asynchronously from the primary to the secondary one. And then, let's say, if the primary goes down, probably your RTO, your recovery time will be, let's say, 5 or 10 seconds, because that's how quickly you can switch your applications from the failed instance to the secondary one. But what's going to be your RPO? Because the changes will send asynchronously, which means that you can lose seconds of data, seconds worth of data, or minutes worth of data. Again, you need to decide. So we are not going to discuss all types of possible database deployments. Let's just focus on the deployment options for transactional applications. My Slack-like messenger is a transactional application. I cannot allow myself, to any data inconsistencies or to data losses, because otherwise it's going to be very damaging. Which means that my recovery point objective is 0. I mean that I am not ready, when whatever database deployment option you offer me, I am not ready to lose a bit of data, okay? If I need to, in case of any outage. But the recovery time objective, it depends. It can take seconds, it can take minutes, it can take more. Again, sometimes I remember when I worked on a project, it was a private data center, and the guys, they needed to have this, no any data loss, that was a financial organization, but then their solution was, if one of the data center, the primary goes down, then we just take backups and we take this physical stuff, storage, and we bring them to the secondary data center. In a couple of hours, the application will be up and running. So for them, it was enough now just to be down for 2 hours. Probably not these days any longer, but those days, that was enough. Probably we no longer live in this world, but that was the case. Speaking about the databases, you can find several options. Again, I will be talking about YugaByteDB for 2 reasons, because at least the first one is, at least I'm 100% sure that all of those deployment options that I will show you are supported by this database. And second of all, I work for this company, I need to talk about this database, right? 2 reasons. So a quick intro, one single slide about YugaByteDB so that you remember. That's a distributed relational database. Think about it as a distributed PostgreSQL. Why PostgreSQL? Because the query layer of YugaByteDB is built on Postgres. Just literally PostgreSQL source code with few enhancements, optimizations. And we always keep up, trying to upgrade to the latest version of Postgres. YugaByteDB does support Cassandra API for those who wish to migrate from Cassandra to YugaByteDB, but our primary focus and the cash cow is SQL. We treat ourselves as a SQL database. The storage layer is what makes us different from Postgres, and we are not competing to Postgres. It's like you either use Postgres, or if you need to have a scalable database, you can easily migrate. The storage is inspired by Google Spanner. Google Spanner is one of the first true distributed SQL databases. And our storage, same as Spanner, it's automatically sharded, distributed transaction, ref, consensus protocol, blah, 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 a lot of the stuff. Okay? So now, let's quickly go back to the deployment options. Let's say that my Slack-like messenger, probably I'm just the very first year of our messenger. We are fully focused on the United States market. Yes, I have Mr. Green, I have Mr. Red, they're disappointed because the latency is high. But at least right now, that's not the priority for me, but the priority for me is high availability. And a single multi-region cluster in the United States might make sense of YugaByteDB. It's synchronous replication, RAT protocol, blah, blah, blah. For me, let's say whenever I need to synchronize changes from the East Coast to the West Coast, which takes 65 milliseconds, that's probably all right now, because I'm not building a trading platform. I'm building a messenger, that's fine. And what's more important, my RPO, recovery point objective with no data loss. If any of these nodes go down or any of these regions go down, the cluster itself will be able to figure this as quickly as 3 seconds. For instance, if one of the nodes doesn't respond to the heartbeats within the 3 seconds, the cluster will eliminate it and they will kind of keep processing the requests. And usually how your application can see it, for instance, the application was connected, let's say, to this node in the west, and then their node went down. Some of your running transactions will be restarted, and those transactions will be executed in other nodes, right? Or let's say if some other users were working with the other nodes, those nodes will not be impacted. The data is sharded. The data that was located on this node, the transactions that were querying the data on this node, the only day you would need to restart, right? The remaining stuff is simpler. But again, with this configuration, it's okay. It withstands region-level outages. But if you're concerned about high latency in distant locations, okay, several options. For the Slack-like messenger, one of the battle-proofed solution, I mean, most of the time people read, and then sometimes they respond, right? And unless we go in an argument or an active discussion, we will be reading, checking, let's say, the discussion threads. And you can deploy read replicas in distant locations, okay? And those read replicas will be used for reads. So Mr. Green and Mr. Red also can serve data quickly. That's not going to be the most up-to-date information because, let's say, all the changes are asynchronously transferred from the primary cluster to the replica nodes. But at least if it's not critical, and for the Slack-like messenger, that's not a big deal. It's okay if I, let's say, don't see the last message that was sent a second ago, but I will see it in 3 seconds. That's okay. That's okay for me. What's not solved here from the performance perspective is that writes, if Mr. Green or Mr. Red need to write to any of these, to send any text to any messages, then these replica nodes will be connecting back to the primary cluster, and the primary cluster will be storing those messages. So the replicas are, just automatically forwarding this write request from here to the primary cluster. So the latency for the writes is still high. There is no any magic here, right? But at least with this configuration, still, you can assume no data loss, and RTO can be as low as 3 seconds. And I'm talking, let's say, just that's my primary cluster. This is where the primary copy of the data is stored. If any of these regions goes down, you're good to go, right? Your application is still available. It's only that for some users, they will see a latency spike in their requests. If it happens that, let's say, my Slack-like messenger keeps growing and I need to make reads and writes performant across all of those major locations, United States, Europe, and Asia, then one of their widespread solutions, you can deploy dedicated clusters, and each dedicated cluster will be keeping data that is related to the users from the United States or from Asia, from Europe. It solves the problem with the high latency, and when it comes to every cluster's availability, still, it's fault tolerant, extremely fault tolerant. But if you need to do the cross-cluster requests, for instance, you need to read messages from here, from there, you need to solve this problem at the application layer. So your application needs to connect to multiple database instances, pull the data, merge this data, join this data. It might be a nightmare, right? So if you don't need to do that, then this solution is good for you. And also, if it happens, then you need to synchronize some of the data, let's say, from the United States to Europe. That's going to be a synchronous replication, which means that if this goes down, there might be data lag, might be data inconsistencies. So again, keep this in mind, right? In my case, what I'm showing here when I'm talking about RPO 0, meaning that no data loss and 3 seconds, I assume that all of these clusters are independent. There is no any asynchronous replication between them, and each cluster is self-contained. They keep the data that is related to the users from this region. The final one, deployment that is supported by many geo-partitioned, many distributed SQL databases, is geo-partitioned cluster. Imagine that you can deploy a single cluster across the regions of your choice, and then in your schema, in your tables, you define a special partitioning column. And based on the value of that column, the database decides where a record needs to be stored or read from. For instance, if the value of I selected it can be named randomly. For instance, in my case, the column name is region, and if the value of this column is European Union, then these records will be stored on the database nodes in Europe. And for you, for the application developer, what you need to do, you certainly need to do these application level changes. Your tables need to be aware of these special codes for your partitioning column, but then you have a single connection to your database, and you send the request, and then the database decides, right? And if to put this together, let's say that Mr. Green connects through the load balancer, through the mobile application. It connects to my app. It connects to the load balancer. Load balancer sees that the application instance in Europe will be processing this request. That application instance in Europe is already connected directly to the cluster, to these nodes. And then it sends requests, and the requests by the database are going to this location, okay? So let's do the final test, fault tolerance. So what's that? HTTP request. Yes, someone was trying to connect to my Tomcat. Interesting. But I think it's up and running. Let's check it. If I go to the that's load balancer. Yeah, it's up and running. Yeah, it's all good. So, but what I will do right now, let me emulate this outage. I will basically, kill this kubectl delete deployment messenger GKE. I'm just deleting this instance. You see that it's stopped abruptly, meaning that, and this is how I sort of emulated the outage in the East. So like there is no longer an instance of my application that is responding to the load balancer. And in the worst case scenario, it can be my database node goes down in that region. Everything goes down in that region, but it's all the same. It's enough to stop just that messenger microservice. And now that's my load balancer. If I start typing, you see the screen is reloaded because the load balancer detected that that instance in the East no longer responding to the requests. And these requests right now are going to be routed to their instance in your central location. So this one is down, right? No, not this one. This one is down. That was the East. And this is the instance in the central. And right now, all of the requests from the load balancer are going through the instance in the central. So easy, right? And then when you restore, when the outage is restored, you can easily, you just redeploy your application instances, and the load balancer will be moving all the traffic back to your closest application instance. And the same stands true for the database. To finalize, so today we were talking about, let's say, multi-region deployments, right, across the United States or across several continents. But how should you start? Because in many occasions when we start, we don't need to deploy across multiple regions or across multiple continents. But still, I would encourage you to put this in practice by doing the following. Whenever you deploy your next application, at least deploy it across multiple availability zones within a single region. This way, you will not be able to withstand region-level outages, but at least zone-level outages will no longer worry you. And then, let's say, if one day some business like management comes and says, folks, we are ready to scale, we are ready to expand to other territories, you don't need to re-architect your solution from scratch. What you can do, then you can deploy your application instances, your database node, and span them across as many regions as you need. Because you already will battle test your multi-region, multi-zone deployment within a single region, and then it's all about, let's say, scaling to other locations. The final slide, this is where you can learn more details. I'm the guy who works with distributed systems, distributed databases for the last 8+ years, and usually these are the books I recommend. Designing data-intensive applications. Database internals is written by a database engineer who commits to Cassandra, but it's written in the language for developers. So if you're hungry to learn more about databases, highly recommend it. This book is for those who build for the cloud and want to learn more about outages and different fault tolerance approaches. Check it out. If you are interested in distributed SQL, distributed relational databases, we have free courses at Yugabyte.com. Some of them are specific to Yugabyte, some of them are generic, so up to you. And if you have any questions to me, you can find me on Twitter. So thanks for coming. And if you have any questions, I will take them off the stage.